Hey guys, today we're taking a look at multiplying polynomials. Now, yesterday we learned that the degree of a polynomial is simply the largest exponent in the polynomial. However, that's when we had a polynomial written in one variable. Today, we're going to take a look at the degree of a polynomial written in several variables. And we find out that the degree is simply the largest sum total of all exponents in one term. So for example, let's just compare and contrast. Here is a polynomial 4x to the fourth minus 1. The degree of this polynomial is 4. Over here we have 3x squared times y cubed. This is a single term here, and it is written in several variables, so the degree of this polynomial is the 2 plus the 3. So the degree here of this term is 5. So this is the higher degree polynomial between these two examples. All right, let's take a look at some classifications of polynomials. A monomial is simply one term. So for example, 4x to the third power, or you could simply have 1/2 x. And those are both examples of monomials. A binomial has two terms. So they're going to be separated by an addition or a subtraction symbol. So for example, 4x cubed minus 1x. Or you could have 2x squared plus 7. Those are both examples of binomials. A trinomial now has three terms. So you could have something like 4x to the third minus x plus 7. And that's an example of a trinomial. Okay, the extended distributive property is simply the distribution property done over and over again. It's the way that we multiply our polynomials. Polynomials. There we go. There's a misspelling for you. So we're going to practice the extended distribution property in our examples today. Before we do that though, let's just practice classifying polynomials. Classify this one and then give its degree. This is 4x. It's a single term, therefore it's a monomial. And the degree is 1 because x is raised to the first power. Our classification for this next one here is a binomial. You can tell because there are two terms, one term and the second term. And the degree on this is 2 because we are going to add the 1 that's on x and the 1 that's on y. Lastly here we have a trinomial. And this trinomial has degree 5. Okay, in example 2, it says to give the degree of each polynomial below. So we have 38m to the 7th n squared. We're going to add the 7 and the 2. That degree is 9. The other term has a degree of 4, but remember, the degree on a polynomial with several variables is the one that has the largest sum total. All right, in example B, we have r to the 5th, x to the 3rd, and z to the 1st, and then plus 2r to the 4th. So again, we have our 5 and our 3 and our 1. That is a degree 9. All right, let's practice our extended distribution property. And simply what the extended distribution property says is you're going to make sure each term in one binomial or polynomial gets multiplied to each term in the other. So when I multiply the monomial here, which has one term, by the binomial, which has two, I'm going to make sure that one term gets multiplied to these two terms. So 8x times 2x gives me 16x squared, and 8x times a negative 4 gives me negative 32x. All right, now we're going to do the same thing for multiplying a monomial times a trinomial. So we're going to make sure this one term gets multiplied to each of the three terms of the trinomial. So when I multiply 7y times 2y squared, I get 14y cubed. 7y now times the positive 3y is plus 21y. And finally, 7y times the negative 1 gives me negative 7y. And I see here that I missed my y squared. There's a 7y and a 3y, so this should be 21y squared. Go back and do that, and I'll make my y here look a little bit more like a y. Why? Because I feel like it. All right, binomial times a trinomial. Again, now I have a 2 terms times a 3 term. So I'm going to make sure each of these 2 terms gets multiplied to all 3 of those terms. And then we'll combine like terms and write it in standard form. So let's go through. We have 5 times our 3x is 15x. 5 times our positive 4y is plus 20y. And then 5 times our 5 is a positive 25. All right, next we're going to go make sure our negative 3x gets multiplied to each one of those terms in that polynomial. So we have negative 3 times a positive 3 is negative 9x squared. Negative 3x and a positive 4y is negative 12xy. And then we have a negative 3x times a positive 5, that's a negative 15x. Okay, let's go through and just make sure we combine all of our like terms. It looks like we have a positive 15x and a negative 15x. Well, when we combine those are actually going to cancel out. And the next task is to make sure we write this in standard form. So our highest degree, highest degree here looks like it's 2. And I'm going to start off by writing it as negative 9x squared minus 12xy. My next one should be plus 20y, and then finally plus 25. So here is my binomial times my trinomial. All right, for our final example today, we have the famous cardboard box volume problem. It says we have a piece of cardboard. It's 24 inches by 24 inches. It's made into an open box by cutting out squares of side x in each corner. Let the volume equal v of x. So we're going to write that polynomial here. Just in case you would like a little visualization, I've taken my square piece of paper and I've cut out x by x in each one of those corners. And now if I begin to fold those up just like a pizza box, then I will have a nice little open box with dimensions. All right, so there you go. And you can see now that those dimensions will be x on its width, and then it'll be 24 minus 2x along each one of those sides. So let's write that as our polynomial here. V of x is equal to x, the length or the width or the height, however you want to say that, times 24 minus 2x times the other dimension, which is also 24 minus 2x. So again, here, if you need like a little visualization of what we just did there, we took our square piece of paper and we cut out these little corners here, the sides. These were gone, bye-bye. And therefore, when we folded it all up, we got this nice little 3D box here. So if we can draw this 3D box like that, where the height here of our box is x. This dimension here is 24 minus 2x, and then along the long edge there is also 24 minus 2x. And we know the volume of a box is simply length times width times height. Okay, sorry for that little segue there. All right, let's find the volume of this box now as a polynomial. So we're going to use our extended distribution property here. We're going to make sure this x gets multiplied to those two. So that gives us 24x minus 2x squared. And now we're going to multiply that again to the 24 minus 2x. When we do that, we are going to end up with 24x times 24. That gives us 576x, and then minus 48x squared. Now we'll do our negative 2x to both of those two terms. That gives us again negative 48x squared, and then negative 2x times the negative 2 gives us a positive 4x cubed. Okay, so in the end, our volume here of this box, written in standard form, should look like this: 4x cubed minus 96x squared plus 576x. Okay, so here's the polynomial that represents the volume of this box, and it says, using your polynomial equation, find the x that should be in order to obtain the maximum volume. So the best way to do this really is to graph this, and I've graphed this function already over on Desmos. So here is our function: 4x cubed minus 96x squared plus 576x. And you can see here our volume is the purple line that's graphed. Our volume is going to increase to this maximum point here when x is equal to 4. And then it's going to start to decrease all the way down here to where it touches the x-axis at 12. So we can see here that when x is equal to 4, our volume will be maximized.